Good evening, ladies and gentlemen of YouTube. So, after a brief pause, I've finally completed my latest DCS Arduino module. It is a lighting panel that has been designed to custom work with DCS. The design of the lighting panel itself had a few challenges. One of the biggest challenges that the lighting panel itself actually faced is that it had needed to be designed in order to work with all DCS modules. The problem with this is the age of the A10C module. Due to the age of the A10C module, when the A10C module was first developed by Eagle Dynamics, the actual module itself did not use an axis control in order to actually operate the lighting panels. Instead, it was assigned a series of joystick buttons. As such, I needed a module that could work with both an axis control and also still able to maintain and function as a standalone design utilizing a button system. So what I did was, when I actually wrote the code, I instigated a A10 override mode. This A10 override mode allowed the potentiometers that we use to control the axes that were assigned to the lights as both a normal axis and also as joystick buttons using a series of presses when those were actually functioned. It's very obvious from the actual design that we've used for the lighting panel itself, where we've actually only got 4 controls for the lights. This goes in the face of a lot of the actual modules itself, where they have multiple light controls. In fact, throughout the modules, the aircraft that seems to have the most lighting controls, US aircraft, is the F-18C, having actually 7 different axis controls to control the actual light systems. With most of these lighting systems, however, a lot of them are multiple ways to control the same thing. For example, within the F5, you have the armament light panel, you have the console lights, you then have the engine instrument lights and the auxiliary lights. So what we've done is we've actually developed one axis, which is effectively called console, and with that we've actually been able to map multiple axes to that single control. So with that simple design, within the code itself, the way that actually works is that when I actually rotate the console light knob we've assigned to it up and down, it controls the x-axis, the y-axis, the z-axis, and also the throttle axis. By then individually assigning those axes to each of the various light controls within the cockpit, you are able to control the multiple axes that you would have to use in order to adjust the light levels inside there. We've kept the floodlight as separate, and we've also kept the formation lights and navigation lights as separate. Now, there are some aircraft where these light systems actually aren't utilized. For example, with the A10C doesn't actually have a navigation lights function. It simply has a formation lights. We've then got around that, of course, by having the position lights with the steady, flash, and off. A beacon light. We then have signal lights for the brightness being controlled as either bright or dim, and then the compass light. In some aircraft, we've actually assigned the compass light to some of the other functions, like in the F5E. So in this particular video now, what you can actually see is you can see us demonstrating how the floodlights work within the actual aircraft itself, and then you will also be able to see the functionality of these console lights. As you can see that every time we actually rotate and adjust the axis, you can see that the multiple axes are being adjusted within the cockpit itself. Then of course you're about to see us as we switch to an exterior view, where you can see the use of both the navigation lights, the position lights, and the beacon light in order to actually control the axis. In this particular case, we actually assign the compass light to work with the landing lights. Once again, as with my previous F5E module that I've done, the idea behind this module and control unit is that it needs to be completely plug and play. This is a little bit more work intensive because you are required to map individual axes whenever you plug it into another computer, but it requires no additional software. When it comes to the utilization of the module within the A10C, there is one slight drawback, and that is that due to the nature of the joystick pushes that's being used, the module samples what the actual axis is displaying on the potentiometer, and if it's increased since the last reading, it adds several button pushes, which has the effect of slowly turning the lights up. Also at the same time, if the reading is less than what it was in the previous one, it's slightly less. The net result of this is that if you are required to now slowly adjust in either an increase or a decrease in order to move it, and as such, if I was to crank it all the way up to maximum in a short period of time, it would not actually translate into probably more than about a third of an increase on the actual lighting scale. This is something that's just inevitable, and it only means that when you adjust these, you need to do so in a small scale to affect the change that you need to do within the module itself. Finally, one of the big questions that most people will be curious to know is how much did it actually cost me to do this? The grand total ended up being under $100, including the fact that I already had the cabling and so forth. I've actually attached at the very end here a list of components and all that. One of the most expensive items is of course the microcontroller. The initial build was done with an Arduino Leonardo, but going forward it's actually going to be constructed now with a Plu Micro. And as you can see, total cost comes to $83.45, not including shipping and handling. That's just the cost of the components. Thank you very much for watching, guys. I hope you enjoyed the video, and I hope that this inspires some of you to do similar projects. As always, I will also provide in the description down below a link to the code that was used as well.